Very good evening to all of you guys. Welcome to BYJU'S Exam Prep. So guys, today we will discuss the next topic of our GATE Champion series, that is basically our environmental engineering, and in this environmental engineering basically we need to discuss the water supply engineering part, right? So I welcome you all once again guys on our platform. So guys, we have beautiful questions from your water supply engineering, and you know that guys, the environmental engineering subject is having a very high weightage in your GATE examination. So no doubt it's a water supply engineering part, wastewater engineering part, as well as the solid waste management and the air pollution is also important. So one by one we will discuss guys, and this particular session will be on every day on the 5 p.m. right? So day after tomorrow we will meet again guys, in which we will discuss the wastewater engineering part. Okay, so kindly share this session to other student also, so that they can join the session and you will get the benefit as well as the other student also. Okay, so good evening Manjeet, good evening to all of you guys. Come fast and join the session. Okay, so let's start it quickly. Okay, so guys, those who are new over here, let me tell you about myself. My name is Krishna Yadav and I'm teaching from last 9 years, and generally my subjects in which I deal is environment, structure, RCC and engineering mechanics. Come fast guys, come fast and join the session, right? So guys, you can register for this particular free GATE Achiever series also on our app. So that is basically ESE GATE 2023, right? You can register on this particular app also, right? So let's start with the question number 1, which is in front of you. Please let me know the correct answer for the question. Tijoram, good evening. Come fast guys, come fast and join the session. This particular problem is a 2-mark problem and it is a NAT type question, numerical answer type question. You need to fill the answer in terms of meter per second. Okay, that is the problem which is given to us. So let's understand guys how we can solve this problem. So what they have given, actually the settling velocity, you need to find out the settling velocity, which is in meter per second. The settling velocity in meter per second of a discrete particle in water under the condition when the Reynolds number is greater than 10 raised to power 4. Now guys, you know that basically there are 3 type of condition. One is your laminar condition, second is your transition, third is your turbulent. Now guys, in this particular case they have mentioned the Reynolds number which you have to use is greater than 10 raised to power 10 raised to power 4. Okay, then it means it is nothing as it is our turbulent condition. So we need to use the formula which is with respect to the turbulent condition. Clear? Okay sir. Now the dia and the specific gravity of the particle is already mentioned. It is 1.2 mm and the specific gravity is equal to 2.65. The water is in at 20 degrees centigrade temperature, and the kinematic viscosity is also mentioned, which is basically 1.010 into 10 raised to power minus 2 centimeter square per second, right? Now do you remember the formula guys, how we can calculate the settling velocity? That general formula, let me write it down. VA square is equal to 4 by 3 G minus 1 into G into D divided by drag coefficient, which is, or coefficient of drag you can write here guys, that is basically CD. This is the formula by which you can calculate the settling velocity easily, right? But what happens when you have the turbulent condition, then the coefficient of drag is not 24 by RE. You need to use the value of CD is equal to how much? It should be equal to 0.4. It should be equal to 0.4. Okay, so let's put the value and get the answer, right? So VS square is equal to how much? It is basically 4 by 3 bracket. G is equal to how much? It is 2.65 minus 1. Small g we can write here guys, 9.81. The dia of particle, it is already mentioned, it is 1.2 mm. You need to convert this value in terms of meter first. So 1.2 into 10 raised to power minus 3. Okay, let's put the drag coefficient over here guys. CD is equal to how much? CD is equal to 0.4. Now please calculate this answer and let me know how much value you are getting for the settling velocity. Tell me guys, quickly. How much you are getting? Please let me know guys. (1.2) multiplied by 10 raised to power minus 3, and then we have to divide this value. Okay, how much you are getting guys? Please let me know the answer. So tell me guys, how much settling velocity you are getting for this particular problem? Please let me know the answer guys. How much it is? Vs is equal to how much? Tell me. Quickly guys, quickly. Anyone who got the answer? 0.2544? 0.2544 meter per second. Are you getting the same value or not? Please let me know guys. 0.2544 meter per second as the settling velocity of this particular particle which we are having, and in this particular case the condition is the turbulent one, right? Very nice. The same answer you are getting. So that's why guys the answer is 0.2544 meter per second, and this is an R type question, right? Numerical answer type problem. Very nice. The next question is basically 1 mark problem, right, which is based upon the Chick's law and the Watson law. Now you need to be careful guys while applying the Chick's law and the Watson law, because you know that guys the data which they are giving over here, it may be possible they will give you the number of microorganism which is present, or it may be possible they will give you the number of micro which is removed from the water, right? So that's why guys be careful with the data first. Okay, now what is given, let's understand in the question. An experiment shows that a concentration of 0.1 milligram per liter, very good Tejaram, you are getting the same answer, right? 0.1 milligram per liter of HOCl which yield an 90% killing of bacteria. That means, can I say that guys, the 90% of bacteria has removed, only 10% of bacteria is present in this case, correct? So NT is nothing as the number of microorganism which is present, how many number of microorganism is present right now? So can I say that guide is it only 10% of the value? Let us suppose the initial value of number of microorganism is n0. So can I write here guys, it is 0.1 times of n0. Clear? Now they have given the time also. The time value is 5 minutes. Now our task is to calculate the disinfection rate constant, which is basically K. Okay, that is our task. So do you remember the formula guys? NT is equal to n0 multiplied by e raised to power minus K into T, and this formula which is given by the Chick's law, right? And what exactly it is saying, the number of microorganism which is present after certain time t when we are having this rate as a disinfection rate, right? That is the concept. So let's put the value and get the answer, and this is 1 mark question right now. So NT is equal to how much? Can I say that guys only 10% is remaining? So can we write here 0.1 times of n0 is equal to n0 multiplied by e raised to power minus K into T. T is 5 minutes. Okay, let's cancel the n0 and ultimately we need to take the ln on both the side. So ln 0.1. Very nice, Eman. Very nice. You are getting the correct answer. You are getting the correct answer. Very nice. 2.3025, and it should be equal to minus 5K. So let's calculate the K value. So guys, we are getting a value of 0.460 per minute. So that's why the correct answer is D. D is the correct answer. Very nice, Aman. Very nice. So D is the correct answer for the problem. It is 0.460 per minute. Clear? Now the next question in front of you, which is basically 2 mark problem again guys, and it is again numerical answer type question. Now guys, mostly what you will get guys in the examination, you will get the question from your alkalinity part, hardness part, some of the chemical conversion also, right? So guys, this is one of the question which is based upon the conversion part, right? In which you just need to convert the concentration of cation in terms of milli equivalent per liter. That is the question, right? So please let me know the answer guys. What will be the answer for the given problem? Please let me know. Okay, and I am solving at the same time. All of you are able to understand the concept or not guys? Tell me guys quickly, which we have discussed in the previous 2 questions. Yes or no? Please write it down. Yes or no? Okay, let's move further. So guys, what is the given in the question? The calcium ion concentration is known to us, that is basically 80 milligram per liter as CaCO3. Now they have given directly what is the concentration of sodium in terms of milli equivalent per liter. Now as well as guys, they have given other concentration also, like SO4 2 negative, total hardness value is also mentioned, Cl negative is also mentioned, NO3 negative is mentioned, HCO3 negative is mentioned. But guys, all these values are in terms of CaCO3. It is not in terms of itself. That means they have not given the concentration of calcium in terms of calcium itself. They have given this particular value, but in terms of what? CaCO3. That is the thing, right? Now what is our task? Our task is to find out the total concentration of cations in terms of milli equivalent per liter. Now guys, what is cation? Cation is nothing as it is the positive charge ions. It is positive charge ions. Now guys, what are the cation which is present in this case? Can I say that guys, the sodium is present over here? Sodium whose milli equivalent per liter value is given to us. So 2.5 milli equivalent per liter is given to us already. Now what is our task? Our task is to find out the calcium ion concentration in terms of milli equivalent per liter. Okay. Now what is basically milli equivalent per liter? Let me explain it. I think all of you know that guys, how we can write the number of equivalent. How we can write the number of equivalent. Number of equivalent. Number of equivalent is equal to how much? That is basically weight in gram divided by equivalent weight, which is also in gram. Equivalent weight, which is also in gram, right? Now guys, if I convert this particular gram value in terms of milligram, then what I will get? Let me explain it. So number of equivalent is equal to, can I write here guys, 10 raised to power 3 multiply by weight in milligram, right? Weight in milligram divided by equivalent weight, which is also in gram. Now just you need to put this particular value 10 raised to power 3 on the left hand side. Then what you will get guys exactly? 10 raised to power minus 3 number of equivalent is equal to weight in milligram divided by equivalent weight, which is in gram. Now tell me guys what it is exactly. This is nothing as milli equivalent, right? So we can write here this value is milli equivalent, and which is equal to how much? It is equal to weight in milligram divided by equivalent weight, which is in gram. Correct? Now guys, I need to divide the value by liter. So let's divide it by liter also. Liter divided by liter on both the side. Okay. So what you will get guys exactly? Milli equivalent per liter is equal to weight in milligram per liter divided by equivalent weight. Now this is nothing as this is the direct formula which you have to use in your calculation part. Clear? But guys, our first task is to convert this calcium ion concentration in terms of milli equivalent per liter. So guys, you can see here the concentration which is given to us for the calcium, it is in terms of CaCO3. Okay. So how we can convert this calcium plus 2 ion concentration in milli equivalent per liter? Can I say that guys, you need to write weight in milligram per liter? How much it is? It is 80 basically. Divided by, now for by which particular equivalent weight you have to divide it? Tell me guys, anyone? It is equivalent weight of calcium or it is the equivalent weight of CaCO3? Because the value which is mentioned over here is in terms of CaCO3, not in terms of calcium itself. You need to divide it by what? Tell me guys. It is calcium, the equivalent weight of calcium, or the equivalent weight of CaCO3? Tell me guys. Quickly let me know guys. Please write in the chat box. All of you. Please let me know guys quickly. CaCO3. Very nice. Very nice, very nice. CaCO3. So guys, what you have to do basically, you need to divide this particular concentration by the equivalent weight of CaCO3, which is basically 100 divided by 2. Now tell me guys how much it is. how much it is? 80 divided by 50, how much you are getting? 1.6. So can I say that 1.6 milli equivalent per liter of calcium plus 2 iron is there? Now there is one more problem. What it is exactly? They have given the total hardness. So tell me guys, if it is total hardness, so we will have two component in this case. One is calcium plus iron, calcium plus 2 iron, and magnesium plus 2 iron. Yes or no? So can we calculate the magnesium plus 2 iron concentration? Magnesium plus 2 iron concentration. What is total hardness? It is 120. What is the hardness which is due to calcium plus 2 iron? It is 80. So can I say that guys, this value is equal to 40 milligram per liter as CaCO3. Clear? Now let's calculate again the concentration of magnesium plus 2 iron, in terms of milli equivalent per liter. Again we need to use the same concept. It is basically 40 and divided by 100 divided by 2. Now tell me guys how much it is? 40 divided by 50. So we are getting a value of 0.8. 0.8 milli equivalent per liter. Clear? Now guys, these are the three value which is nothing as our concentration of cations in terms of milli equivalent per liter. Now as a final result, we need to add all three values, right? You need to add all three values. So let's add it. One is your sodium, then we have calcium, then we have magnesium. So total cation concentration, in milli equivalent per liter, it is equal to how much? That value is 2.5 plus 1.6 plus 0.8. Let's add it and let me know the answer guys, how much it is? 2.5 plus 1.6 plus 0.8. How much you are getting? 4.9 milli equivalent per liter. Crystal clear guys? Crystal clear to all of you? So the answer is 4.9. Very nice, Aman. 4.9 milli equivalent per liter. Clear to all of you? Very nice. Let's move to the next question. Next question in front of you. Now this question is based upon your population forecasting method, and I think all of you have learned that method, which is basically our logistic curve method. And let me add one more point over here guys. Whatever method you are using to forecast the population, all the methods are giving the approximate calculation. No one will give the correct answer, or no one will give the exact answer which will be in future. Why? Because no one can predict the future, right? It is not possible we can predict anything after 5 minutes or after 10 minutes or after 1 year also, right? So because you know that guys, let me give you one example also. No one knows about the coronavirus, right? So at that particular time, the death rate has increased. So how we can predict the such type of situation will occur in future, right? So that is the reason guys, due to which we are not able to estimate the exact population by the method which you are using over there, right? But we can calculate it approximately. So whatever method you are using, it doesn't matter, but all the methods are giving the approximate answer only, not the exact one. Okay, but let's solve the question. So guys, in this particular case, we need to use the logistic curve method equation. So if the population of a growing town in a 3 consecutive decades are these, okay, then the saturation population of the town is equal to 60526. Okay, the value of n is already mentioned, m is already mentioned. Now the question is, after how many duration the value of population will be this? That is the question. So do you remember the formula guys to calculate the forecasted population by logistic curve method? Pt is equal to p set divided by what? Divided by 1 plus m time ln inverse bracket n into t. This is the formula, right, to calculate the population by using logistic curve method, right? Okay sir. Now let's put the value over here. Pt is equal to how much? They have already mentioned, it is 58278, and the saturation population is equal to how much? 60526. Okay, rest of the thing we have to put again guys. 1 plus m is equal to how much? M is equal to 9 ln inverse n is minus 0.11 into t. Now our task is to calculate the t value. Okay, let's do it. 60526 divided by 58278. So let's write it down. 1.0385. Okay, let me write in this way. So guys, we'll put this particular value on the left hand side, right, which is 1 plus 9 ln inverse bracket minus 0.11 times of t, and it is equal to, you need to divide this value by this one. So we are getting a value of 1.0385. Okay, so guys, let's solve it further. How much we are getting? Let's see. Divide by 9, then we need to take ln, divide by minus. Okay, so guys, we are getting as an answer t is equal to, after solving this, how much you are getting? 49.56 year. 49.56 year. We are getting 49.56 year. Please remember this point also, guys. The time which you have to put in the logistic curve method, it is in terms of year. But what happened in other cases, we are trying to put in terms of decade. Okay. So t is equal to 49.56 year. So which particular answer you can take as a correct answer? The 50 year. 50 can be the answer for this problem. Yes. How to calculate ln inverse? It is very simple. What you can do? Very simple, Tejoram. What you have to do? Just subtract this value from 1, then divide it by 9. Okay. Then take ln on both the side. Okay. So this particular value will get removed, and ultimately you will have, let me show you that calculation so that you can understand it very well. Okay. 1 plus, you can write 9 ln inverse minus 0.11 times of t. If you subtract this 1 from this value, you will get 0.0385. Okay, now you need to divide it. So 0.0385 divided by 9. So we are getting a value of 4.277. No issue, Tejoram, I will explain it. Now take the ln on both the side. If you take the ln, it will get cancelled, and you need to put ln over here only, right? So if you take ln on both the side, so this value will become 0.11 t, and ln 4.277 into 10 raised to the power minus 3. Now calculate it further. Clear? Now calculate it further. Clear? Okay. So you will get the same answer which we are getting over here. T is equal to 49.56. Clear? Next question, guys, which is related to the solid concentration, right? So sometime they are also trying to put the question which is related to the suspended solid concentration, right? Volatile suspended solid, non-volatile suspended solid, and etc. So guys, this particular topic is also important as per your examination. Let's solve this question, guys. Okay. So during a proximate analysis, the 50 gram of sample is oven dried for 24 hours at 104 degrees centigrade. Let us suppose we are having a sample over here. We are having a sample over here whose weight is given to us, and that weight is equal to 50 gram. This weight is 50 gram. Okay. Now we have put this particular sample for an oven dry process for 24 hours at 104 degrees centigrade. 24 hours at 104 degrees centigrade. Now what will happen, guys? After cooling down, a residual weight along with the crucible was observed to be equal to 21.246. Okay. So now you have oven dry it. So ultimately the weight of sample and the weight of crucible, both the values are included in this case, guys. So this equal to how much? It is 21.246 gram. Clear? Now anyone who can tell me, guys, anyone who can tell me in this particular case, if you oven dry it, whatever moisture is there, it will get removed. Correct? It will get removed. Now the solid which you are having is what? It is basically total solid, or it is dissolved solid, or it is a suspended solid. Tell me, guys. It is dissolved solid, total solid, or suspended solid? That is the question. Tell me, guys. It is basically total solid, right? Whatever value you are getting over here, guys, that is basically the total solid. Very nice. Total solid. Now this particular sample again, yes, very nice, yes, and Tejoram. Now this particular sample was again putted in the muffle furnace at a temperature of 550 degrees centigrade for 2 hours, right? Initially it was putted in the oven, then after that, guys, we have putted it into the muffle furnace. Okay. Now, guys, what you need to do? You need to check it out. What is the weight after this particular process? The weight of crucible was again weighed and obtained as a 21.021. Okay, sir. So you can see here, guys, the weight of crucible plus weight of sample which we are having right now, it is equal to 21.021 gram, right? Now tell me, guys, after your muffle furnace process, right, what type of solid is remaining in this particular case? Anyone who can tell me? In this case, you know that it is total solid. Okay, let me write it down. You know this, it is total solid. What about this one? It is dissolved or it is a volatile, non-volatile? Tell me, guys. It is volatile, non-volatile? It is basically non-volatile solid, not dissolved. You can write here, guys, it is non-volatile solid, basically non-volatile solid. Guys, I am having some disturbance from the back side. You can do the further calculation. Just a second, right? Shaz, wait a minute. Actually, some sound is coming from my background. That is the reason I am not saying anything, right? But no issue. Let's continue the session. I am not able to stop such type of sound, right? But no issue, guys. Let's continue the session. Okay. My audio is clear to all of you? My audio is clear to all of you? My audio is perfect? Okay, let's do the further calculation. Okay, no issue. So guys, you can see here, this particular solid which we are having is a non-volatile solid, and this particular solid is basically what? Total solid. Now our task is to calculate the volatile solid which is in percentage and the non-volatile solid which is also in percentage for the sample. That is our main task. Okay. Now the question is, first I wish to calculate the amount of non-volatile solid which is present in the sample. Okay. How we can calculate it? The weight of crucible plus the weight of total solid is equal to 21.246, and the weight of crucible plus weight of non-volatile solid is equal to this one. So if I subtract these two value, I will get the volatile solid concentration, correct? So let's do it. So let's write, guys, the weight of volatile solid, the weight of volatile solid, the weight of volatile solid is equal to how much? Can I say that, guys, this value minus, sorry, this value minus this value, it is 21.246 minus 21.021 gram, right? If you subtract it, then how much you are getting as a weight of volatile solid? So we are getting a value of 0.225 gram, 0.225 gram as a volatile solid concentration. Now our task is to calculate the weight of non-volatile also. Non-volatile solid, how much it is? Non-volatile is equal to how much? Now they have given the weight of crucible also. Yes, they have mentioned the weight of crucible is equal to 19.996 gram. So guys, if I subtract the value, listen carefully, if I subtract this value from weight of crucible, I will get the weight of non-volatile solid, correct? So let's write it down. It is basically 21.021 minus 19.996. How much it is? Let's calculate. So guys, we are getting a value of 1.025 gram. Okay, now what is our task? Our task is to calculate in terms of percentage, right? Right now we are having the weight of volatile solid and non-volatile solid in grams, but I need to calculate it in terms of percentage. So what is your total solid which was present? How you can calculate it? What is the total amount of solid which was present earlier? Total amount of solids. Total amount of solid is equal to how much? This value minus weight of crucible. So 21.246 minus 19.996. If I calculate it, I will get the total amount of solid. 21.246 minus 19.996. So we are getting an answer of 1.25 gram. Okay. Now let's calculate in terms of percentage. So percentage volatile solid. Percentage volatile solid is equal to how much? Can I say that, guys, this value which is basically 0.225 divided by total solid, divide by total solid, multiply by 100. Calculate this percentage. How much you are getting? Please let me know. So guys, we are getting 18%. 18% as a volatile, not 5%, right? 18%. And the rest of the thing, I think it is non-volatile in nature. But let's calculate. Let's calculate it. Non-volatile solids. So can we write here, guys, this value is equal to 1.025 divided by 1.25 and multiply by 100. So 82, are you getting 82 exactly? Very nice, superb. Yes, 82%. So you can see here, guys, this is the answer. This is the correct answer, right? So this value volatile is 18% and 82% is non-volatile in nature. Now tell me, guys, how this question, all of you are able to understand the concept or not? Tell me, guys, quickly. How's this question? All of you are able to understand the concept, how to calculate in terms of percentage? Very well. Very well, guys, very well. Superb. Now let's solve a MSQ question, guys, which is in front of you, and it is a 2-mark question, right? It is basically 2-mark question, MSQ question. Okay, be careful while solving this type of problem. Whenever you have an MSQ question, guys, you need to read it very carefully, because they can twist the question in the option also, right? Not in the statement of the question, they can twist in the option also. That is the reason. So let's understand, guys, how we can solve such type of question. The settling basin at a water treatment plant having a flow rate of 0.6 meter cube per second, and the effective settling volume as an effective settling volume, that is basically 20 meter long, 3 meter tall and 6 meter wide. Now which of the following statement are true? You need to find it out, right? What are the following statement which is true for this particular case? Okay, so before solving it, guys, we are able to see here they are trying to relate the question with respect to the percentage removal. So whenever we need to calculate the percentage removal, I need the design settling velocity of the tank first. So let's calculate the design settling velocity first. Design settling velocity is equal to how much? Design discharge divided by surface area. That will be our calculation. So design discharge is already mentioned, which is 0.6 divided by surface area. So surface area is L cross B, right? That means 20 into 6. So we are getting an answer of 5 into 10 raised to power minus 3 meter per second as a design settling velocity, right? As a design settling velocity. This is our design settling velocity. Now let's calculate the further thing. Guys, what is given over here? 60% of particle having or have a settling velocity of 0.003 mm per second will be removed. Can we calculate if we having settling velocity of 0.003 mm per second, then how much percentage of particle can be removed? Let's do it, guys. Okay, so percentage removal is equal to US divided by VS multiplied by 100. Let's do it. US is equal to how much? This value is given in the option, 0.003 divided by 5 into 10 raised to power minus 3, then multiply by 100. Please do this calculation and let me know the answer, guys, how much you are getting. Do this calculation and please let me know how much you are getting. So right now we are getting as a 60% as the answer. Now tell me, guys, the first option is correct? The first option is correct. A is correct, right? You are able to remove the 60% of the particle whose settling velocity is 0.003. Bacha, you are from the electrical engineering and I am a faculty of civil engineering basically. So whatever reason you are having, why you are not getting the call from the PSU, that you need to consult with the some double E faculty, right? That will be much better. Okay, let's solve the next question. Are you from electrical engineering or you are talking about the environmental engineering gate? Okay, let's solve the next question, guys. Next statement. If the length is 15 meter, in place of 20 meter long, if we put 15 meter of the sedimentation tank as a length, then removal efficiency of particle whose settling velocity is 0.003 is 45. Okay, let's solve it. Now, guys, what will be the change in this case? Environmental engineering. So it will depend upon the situation, right? Like if you are having the rank 116, whether the PSU which you are trying to apply, right, in that particular PSU, whether they are trying to, means whether they have mentioned the double E students, means the environmental engineering students are applicable to that particular job or not, right? That is the situation. It doesn't matter whatever rank you are having. That means the criteria is also it to be fulfilled, right? Okay. Okay, RR. Okay, guys, let's solve. But in this particular case, what will happen? The settling velocity, which is basically our design settling velocity, will get changed in this case. Why? Because the value of length is changing. So QD divided by AS, surface area. So design discharge is equal to how much? It is 0.6 divided by surface area. In place of 20 meter long, you need to put 15. 15, then we have 6. Okay, let's calculate it. 0.6 divided by 15 divided by 6. Okay, guys. So we are getting a value of 6.66 into 10 raised to power minus 3 meter per second. Now let's calculate the percentage removal again. US upon VS multiply by 100. So US value is, I think it is same, 0.003, which is given in the question, right? Okay. And this value which we are having over here, Guys, wait a minute. I think they have, there is one mistake in the dimension, right? This dimension you need to write as a meter per second, not a mm per second, right? If you write mm per second, then the solution will be a different one, right? Because this value which we are getting is a meter per second, right? I think this this is a typo error, right? This one is a typo error. Please consider this value which is we are having, it is in meter per second. Okay. So next one is your 5 into 10 raised to power minus 3, not 5 into 10 raised to power minus 3, it is 6.66 multiplied by 100. Okay. Tell me guys how much it is. 45%, very nice, very nice. 45% we are getting over here, guys. 45%. So this statement is also correct. This statement is also correct. Very nice. Now let's understand the next question, next statement. Now you can understand, guys, if you have the same statement over here, and in this place they have written just in place of 45 they have written 75. So this can be not be the correct answer. You need to understand this point, guys. Very easy point. So this particular answer will be the wrong. C is the wrong, right? Now what about D? The surface overflow rate depend upon the width and the length of the tank. SOR value. You know that, guys, SOR can be written as QD divided by surface area. So QD by what? QD divided by length into width. Now tell me, guys, yes, it will depend upon the surface area. Yes, it will depend upon the length and the width. So that's why, guys, D is also correct. So A, B, D are the correct answer for the problem. Crystal clear to all of you? Tell me, guys. It is crystal clear to all of you? Very nice, very nice, very nice, Shians, very nice, Iman. Both are you are getting the correct answer. Tejaram, very nice, very nice. Let's move to the next question, and this is a MSQ question, guys. 1 mark problem. Please let me know the answer from your side only. Okay, please solve it, and you need to tell me the answer from your side only. Okay, I will not explain right now, but you need to tell me the correct answer. MSQ 1 mark question. MSQ 1 mark question. Which of the following are the correct? Pumps are employed in the water supply project at the various stages. You need to apply the pumps in the various stages of the project. So tell me, guys, where you have to apply it, right? That is the question. Quickly tell me the answer, guys. It is A, B, C, D. MSQ question, 1 mark question. Tell me. Tell me, guys, quickly. A, B, C, D. Which of the following answer is the correct for the question? Guys, you will get this particular PDF on my Telegram channel. I will share you the link over here so that you can download this particular PDF as well as the solution. All, very nice, all. Very nice, Iman, very nice, Shians. What about the students? Tell me, guys, in all the places we need to apply the pumps. Now let's understand what it is exactly. What is the process of pump? Why we are using pump? To increase the elevation or to have the pressure in the water or to supply anything from one location to another location. That is the requirement of pump, correct? Now let's understand this statement, guys. To deliver the treated water to the consumer at the desired pressure. So in that particular case also we can use the pump, right? The next one is to supply the pressure water for the fire hydrant. Again, you need to use the pump, right? To backwash filter. Now you remember, guys, when we are backwashing our rapid send filter, in that particular case, I need to supply the water in a pressure form. So again, I need to use the pump. So that's why C is also correct. What about D option? To pump chemical solution needed for the water treatment. You know that, guys, sometimes we have to use the coagulant in our process, disinfectant our process. So in that particular situation also you can use the pump so that you can have the desired pressure and desired rate for the chemical solution. That's why A, B, C, D are the correct answer. Very nice. Next question in front of you, guys, and in this particular problem what you have to do, you need to calculate the alkalinity. But guys, I am giving this particular problem as a homework to all of you. Okay, because such type of question we have already done, like not done right now. Okay, but no problem guys, you can do it by yourself. Are you able to solve it? Then we will discuss the further question. This question as a homework. Please try to solve it and let me know the answer guys. Okay, you can paste your answer or you can put your answer in the comment box after this video also, right? Are you able to solve it? Yes or no? Tell me guys. Otherwise I will solve it in front of you. Okay, very nice. Do it guys, do it. You can do this particular problem, very easy problem, I think so. Let's solve the another question, which is question number 9 in front of you. Be careful while matching the option. Okay, this is a MCQ type question which is for 1 mark. One mark question. Okay, tell me the answer. You just need to compare. There are two basin over here. One is a rapid mixing and second is flocculator basin. One is flocculation process and the first one is your coagulation process. You need to tell me guys which one of the following is the correct answer over here. One is rapid mixing. Rapid mixing itself is saying this particular process can occur in a shorter duration, right? So I am giving you a hint to solve the problem. Rapid mixing is what? Basically a coagulation process. Now the name itself is trying to suggest us the time duration which we have to put is should be lesser, right? So tell me guys, for A it should be X or it should be Y? For A it should be X or it should be Y? For A it should be X or it should be Y? It is Y. Why? Because the time duration which is required is 0.3 to 1 minute, which is a very less duration, and such type of duration we need to put in the rapid mixing process. Okay. The next one is, if we talk about velocity gradient, right? This velocity gradient is nothing as it will tell us guys how much power you need to provide in the motor so that you can have a proper mixing, right? So in rapid mixing process, what we are trying to do, we are trying to mix our water with our coagulant in a very rapid form. So in that particular case, the power which is required is proportional to the velocity gradient, right? So basically if you have more power, then more velocity gradient. So in rapid mixing process, the velocity gradient is very high. So that's why guys, for A it should be 1, right? So 1 and Y. So can I say that guys, for flocculator basin, this one is the answer and this one is the answer. So that's why A is the correct answer for the problem. A is the correct answer. Crystal clear? Let's solve the next question. Next question in front of you. Tell me the answer guys for this problem also. Chlorination is a process of disinfection. After breakpoint chlorination, if we add chlorine, then which type of chlorine residual form? It is combined chlorine, it is free chlorine residual, both A and B, neither A, neither B. Tell me guys. C, both A and B, okay. Guys, you have to be careful, right? While putting your answer, you should be careful very. D. Any other student who want to give the answer? Very simple question, but it based upon the logic which you have understood while studying the chlorination curve. Simple question, but it's a logical one. D, Shian C, okay. Guys, do you remember basically after this particular point, which is basically our breakpoint chlorination, right? This is basically BPC, breakpoint chlorination. Before BPC, whatever chlorine residual you are having, that is basically your combined chlorine residual. Combined chlorine residual. And why this combined chlorine residual is formed? Because of presence of some nitrate compounds, or you can say that some chloro-organic compound, means some organic compound are there which is trying to react with the chlorine, and such type of reaction will give us the combined chlorine formation, right? Guys, after this particular BPC point, if you add the further amount of chlorine, it will get converted directly into the free chlorine residual, because there is no one who is trying to react with the chlorine further, and that's why it is known as BPC point, right? So whatever chlorine which you are adding after this particular point, all will get converted into free chlorine residual, right? Now tell me which one is the correct answer. It is B basically, not A, not C, not D. So whatever chlorine residual form you are having after BPC point, that is basically free chlorine residual only. Clear guys? It is clear? Clear to all of you? Very nice. Let's solve the next question which is in front of you guys. Next question. Very nice. The chlorine is used as a disinfectant in a municipal water treatment plant. It achieves 50% of disinfection efficiency measured in terms of killing the indicator organism, which is basically E. coli, in 3 minutes. The minimum time required to achieve the 99% efficiency for disinfection would be. So guys, let's calculate this. This particular problem is again based upon the Sixth law, right? So you know that NT is equal to what? N naught multiplied by e raised to power minus kt. Okay. Now in this particular problem, what they have suggested, the 50% of microorganism has killed, right? That means in 3 minutes, 50% of microorganism has removed. That means the number of microorganism which is remaining is 50% of initial value. Multiply by e raised to power minus k. K is equal to how much? We don't know. Multiply by 3. Now we can cancel this and let's calculate the value of k, guys. How much it is? We are getting a value of k is equal to 0.23 per minute, right? Now our task is to calculate how much duration is required to have the efficiency of 99%. So guys, if you have 99% efficiency, that means only 1% of microorganism is remaining. So let's write it down. 0.01 times of n naught is remaining right now, which is equal to n naught e raised to power minus the disinfection rate constant is remain same, 0.33 multiplied by t. Now let's cancel these two values. Let's take ln on both the side again. And divided by 0.33. So we are getting a value of how much we are getting, guys? 0.23, not point. It is 0.23. Okay. ln 0.01 divided by 0.23. So we are getting a 20 minute approximately. How much you are getting, guys? Exactly. Anyone who can tell me the answer? Because we are having little bit difference in the, means very less difference between the answer. That's why we need to calculate it exactly, right? Do it exact calculation. Do the exact calculation over here. Wait a minute, guys. Wait a minute. We have to do an exact calculation over here. Otherwise, we are getting a different answer. Let me explain it. So let's write it down, guys, completely. What it is exactly? 0.23105. Okay, per minute. Per minute. Now we need to remove 99% of microorganism. Remaining is 0.01. N naught is equal to n naught into e raised to power minus k. K is equal to how much? 0.23105 multiplied by t. So guys, we are getting a value of t is equal to 19.93. That is the reason, guys. That's why I am suggesting you need to use the value which is after the decimal, like 4 to 5 digits, right? then only you will get the correct answer. Why? Because in this particular case they have very close options, 19.93, 21.93 and exact, right? So that's the reason, guys. The answer is C. C is the correct answer for the problem. C is the correct answer. Crystal clear? C is the correct answer. Very nice. Next question in front of you. Next question in front of you, which is based upon backwashing process. Which is based upon backwashing process. Now what they are writing over here, let's understand the question first. A 0.8 meter deep bed of sand filter whose length is equal to this, width is equal to this, is made up of uniform particle whose size is equal to 0.4 mm per second and the specific gravity is equal to 2.65. Okay, now the bed is having a porosity of 0.4. The bed has to be backwashed at a flow rate of 3.6 meter cube per minute. The backwashing will discharge is basically 3.6 meter cube per minute. Now during the backwashing, the terminal settling velocity of the sand particle is equal to this, then the value of expanded bed is equal to how much? Now you need to tell me, guys, what is the depth of expanded bed in this particular case? Do you know how to calculate it? And what is the relation between the porosity before backwashing and after backwashing? Do you know the relation, guys? Tell me. Do you know the relation? Okay. No problem. Let me explain it. So guys, let us suppose the initial condition of the bed is nothing as, प्रणाम युवराज, बहुत दिनों बाद देखा है आपको, कैसे हो बच्चे? How are you? So this value is basically 0.8 meter and this value is nothing as initial value, right? Which you can write here, guys, as a D. Let us suppose D. D is nothing as the depth of the filter bed initially. Correct? The dimension is given to us like our length and the width of the filter bed is already mentioned, and the particle which we are using over here is whose dia is equal to 0.4 mm. Okay, specific gravity is equal to 2.65. The bed porosity initially unexpanded condition is 0.4. Okay sir, okay. Now there is one relation, guys. There is one relation which we have to use over here. बढ़िया है बच्चे, बहुत अच्छी बात है. आई होप आपको अपनी मंजिल मिले सबको ही, है ना? मैं यही चाहूँगा बच्चों, जितने भी बच्चे पढ़ रहे हैं, दो स्टूडेंट हुआ लर्निंग ओवर हियर, ऑल यू विल गेट दी योर डेस्टिनेशन, राइट? आपको अपनी डेस्टिनी, आपका सक्सेस मिल जाए, बस ये मेरी उम्मीद है ना? थैंक यू सो मच. चलिए जी, सो लेट्स कैलकुलेट इट फर्दर. सो यू नो दैट गाइज द रिलेशन इज देयर, 1 minus theta expanded multiply by g minus 1 into d dash is equal to 1 minus theta bracket g minus 1 into d. This is the relation, guys, which you have to use. Now tell me, the specific gravity of particle before expansion and after expansion, it will not change. If it is not changing, can I cancel these two values? Right? Because what is expansion? Expansion is nothing as, this is your expanded filter bed, right? Right now, in which you have some given the backwashing discharge, right? So the value of d dash is unknown to us. Our task is to find out the d dash, and the theta expanded is also not mentioned. It is also not mentioned, right? Okay. Now let me explain one more point. How to calculate theta expanded? There is one relation, guys, which you have to use. Theta expanded is equal to backwashing velocity upon settling velocity rest power 0.22. This is the relation we can use, which is an empirical relation to calculate the theta expanded value, correct? So theta expanded. So guys, backwash velocity is already given to us indirectly. You can see that the backwash discharge is mentioned. The backwash discharge is already mentioned, which is equal to 3.6 meter cube per minute. Can we calculate the velocity over here? This is discharge divided by what? Surface area. And what is the surface area? 4 into 3, we can calculate this value. Point 0.3, can I say that guys? 0.3 meter per minute is the backwash velocity. 0.3 meter per minute. So let's put this value. And I think they have mentioned the terminal velocity, which is settling velocity, 0.05 meter per second. Okay. So guys, this value backwash velocity is equal to 0.3 meter per minute. But I need to convert it in terms of meter per second divided by 60. Backwash velocity 0.05. Bracket rest power 0.22. Please calculate this value. So we are getting a value of 0.6025 as a neta expanded. Let's put the value further. 1 minus 0.6025. D dash is not known to us. We know the value of neta. Neta is equal to how much? Before expansion, the porosity is equal to how much? 0.4. 0.4. And D value is given to us. Yes, it is 0.8 meter. So please calculate the D dash value and let me know the answer, guys. How much you are getting? (1.2) 1.2075 meter. All of you are getting this particular answer or not? (1.2075 meter). Very nice, Shans. Very nice, Aman. Very nice, very nice, very nice. Now the next question, which is basically a MSQ type of problem. Please tell me, guys, which of the following statement are correct, and this problem is based upon your distribution system. We have solved a lot of questions, guys, on different topic like alkalinity, like chemical calculations, suspended solid, filtration process, disinfection process. We have solved a lot of questions, as well as population forecasting, right? And all these topics are important. So that's why, guys, this session has mixed type of question. The same type of session you will get, guys, on Monday again, right, at 5 p.m. On Monday again I am taking a session, guys, at 5 p.m. right, but it should be on wastewater engineering, right? So you can join that session also at 5 p.m. on the same channel, right? Tell me the answer of this one, then we'll close the session, guys. Which of the following statement are correct for the water distribution system? The suitable layout for a water supply, an irregular grown town, is a dead end system. The first statement is correct or not? For any irregular, or you can say that unplanned town, if you are planning a dead end system, then it will be much better, because there is no initial planning of the town, guys. That's why you can use the dead end system very easily. Correct? The first statement is correct. In the water distribution system, leakage can be. Yes, Shans, I will do definitely, and that's why we have one session on Monday, right? Let me write it down. On Monday I will come back again at 5 p.m. right, in which we will discuss the wastewater engineering. After that we will have on Tuesday also and Wednesday also. Tuesday and Wednesday, I think one is solid waste management and the next one is air pollution, right? Okay, now tell me, guys, the second statement. Rajneesh and Shivansh, Tejoram, Eman, please let me know. In water distribution system, leakage can be detected by the sonoscope. Leakage can be detected by the sonoscope. Correct? Correct? This statement is correct or not? It is correct. Yes, sonoscope is to be used to detect the leakage basically, right? Hardy-Cross method is most widely used for analyzing and designing pipe for all the type of complex water distribution network. Hardy-Cross method is most widely used method tell me guys. No idea. So this is also correct. Very nice. What about other students? What do you say? This statement is correct or not? For designing of water distribution network, are you using the Hardy-Cross method and most widely method? Yes. In the radial water distribution system, the flow from periphery to center. In radial distribution system of water, how your water can flow? It is from periphery to center. What about D statement, guys? Statement number D. Statement number D. What do you say? In radial water distribution system, the flow from periphery to center. Center to periphery. Okay. Any other student? Center to periphery. Okay. Guys, what happened basically in case of radial distribution system? Let me explain it. How it look like. Let me show you that first. In radial system, what will happen? We are trying to divide the zone, right? This is our main pipe. Okay, this is our main pipe. By using this main pipe, we are trying to put some distribution tank, overhead tank. You can say that this is overhead tank where we will supply our water like this. So you need to supply the water like this from your main pipe. And this particular tank is trying to distribute the water to the zone which we have divided. Now tell me guys, in radial water distribution system, the flow is from periphery to center. It is correct or wrong? No, it is not correct. This is basically your periphery. This is basically periphery, but the water is flowing from center to periphery basically. You can say that, right? So that's why this statement is wrong. So only A, B, C are the correct answer for the problem. Clear? Clear to all of you guys? It is clear to all of you. That's why A, B, C are the correct answer. Okay. Now guys, there are two questions which is as a homework. This is the last problem of the session which I am giving as a homework again, right? This is the last problem which you have to solve by yourself. So question number 14, and there is one more question, question number 8. These are the two questions which you have to solve as a homework, and please tell me your answer guys, how much answer you are getting or which of the following option is correct. Okay, that you have to tell me in the comment box of this particular video. Okay, what you can do guys, I will share the link over here of my Telegram so that everyone can join this particular Telegram link, as well as you can tell me, I will give you the PDF of this session so that you can have this particular solution with you as well as the question part. Okay, so I am sharing a link over here guys which you can join, from where you will get this particular PDF, right? Just a second, right? I'm sharing a link. Thank you man, thank you so much. Thank you Tejoram. So guys, you can join this particular Telegram and ultimately you will get this particular PDF in today, right? In today condition, right? I will send this particular PDF in my Telegram channel so that you can download it. So let's meet on Monday guys again at 5 PM, right? We will have the session at 5 PM, right? So let's close the session. Let's meet on Monday guys. Any doubt, any query if you have, please let me know. Otherwise we can close the session, and please download the BYJU'S Exam Prep application from Google Play Store also, so that you can have the further free session. If you want to join, you can join it on our application also, right? Okay. Bye guys, take care, thank you so much. Let's meet on Monday directly, right? Bye, take care, thank you so much.